All right, so today we are going to review 3x3 systems of equations. We're also simultaneously going to review how to convert systems into matrices so that we can solve them that way. So when we are solving a system with 3 variables by hand, which you are going to be required on your quiz to solve one of the 3x3s by hand. First, you use either substitution or elimination to get it down to a 2x2 system. So I generally prefer elimination, but it kind of depends on the system itself and what we're going to try. Once you have it down to a 2x2, then we do the exact same thing that we did in the last lesson. Just solve it either using substitution or elimination. That'll give you 2 of the 3 variables. And then you take those answers and you plug it back into one of the original equations to solve for your 3rd variable. In the last lesson, remember all our answers should be ordered pairs. Because we now have 3 variables, all our answers in this section should be ordered triples. Should be alphabetical order, so I put X, Y, Z here. If you're using variables other than X, Y, and Z, then just make sure that in the triple that they're listed in alphabetical order. Okay, so we're going to look at our first example here. And remember that our first objective is to get a 2x2 system. So the first thing that I notice when I look at this system is that my second equation down here only has 2 variables. So it only has the X and the Y. So really the quickest way to get a 2x2 here is to take equation 1 and equation 3 and eliminate the Z. Because if I can do that, then I'm going to have it down to 2 equations that only have X and Y. Now, when I look at my Z's, they are definitely not already opposites. So that means that I'm going to have to multiply the equations by constants in order to get opposites. In this case, I'm going to multiply equation 1 by 3. The way that I usually note, because it's important that your work is really organized, if you just have a mess of work randomly in places, if you don't get the answer right, I'm not going to be able to tell what you've done. So I would suggest very clearly marking what you're doing. So here, I'm just going to write out 3 times equation 1, so I circle the equation number. And then equation 3, I'm going to multiply by 5, so 5 times equation 3. So that way, everybody should understand what I'm looking at. So when I multiply equation 1 times 3, that's going to give me 6x minus 12y plus 15z equals negative 99. Then, when I multiply equation 3 by 5, that's going to give me negative 10x plus 10y minus 15z. And then 19 times 5 gives me 95. So now, by multiplying by those constants, I've obtained opposites on my z's. So I've got 15z and negative 15z. Once I have opposites, that means I can go ahead and add. So add straight down in the columns. That gives me negative 4x. And then I get negative 2y. The z's are eliminated. And then when I add the constants, I get negative 4. So I've got negative 4x, negative 2y equals negative 4. So this system only has 2 variables. It purposefully has the same 2 variables as this equation that I started with. So now I'm going to take those 2 together and I'm going to solve this 2x2 system. So in order to do that, I am again going to use elimination. If you prefer substitution, that is totally fine. In this case, I've really already got opposites on my x's, so it makes sense definitely to use the elimination method here. So when I add the columns now, The x's are eliminated. I get negative 3y, and then I get negative 9. So divide both sides by negative 3, and that gives me y equals 3. So I now know what y is. I can choose either of these two equations to plug that y into. I'm going to choose this one since it's a plain y instead of a 2y. So I know that 4x minus 3 equals negative 5. So solve for x means I'm going to add the 3 to both sides first. That gives me 4x equals negative 2. And then divide by 4. Now, I always get people who just aren't paying close attention who might say this is negative 2. Look at what your numerator and denominator are. The 4 is in the denominator, the 2 is in the numerator. So this is not negative 2, this is negative 1/2. So x equals negative 1/2. So now I've got my x, I've got my y. If you're looking at your steps, I've finished the second bullet point. So now I go to the third. I'm going to plug all those answers into one of my originals. It needs to be one that actually has z in it, otherwise I'm not going to be able to solve. So I'm going to go ahead and plug into the top equation. So I've got 2 times x, so 2 times negative 1/2, minus 4 times y, which is 3, plus 5z equals negative 33. So now I simplify. This gives me negative 1 minus 12, which is negative 13. I'm going to add 13 to both sides. That gives me 5z equals negative 20. And so now I have z equals negative 4. So last bullet point is to list as an ordered triple. So I've got negative 1/2 for my x. I've got 3 for my y and negative 4 for my z. Remember that anytime you're solving a system, this is true for 2x2s as well, you can always check your answer by plugging it in. If it truly is a solution, it should work in all of the original equations. So if you're not sure, that's kind of a way you can check yourself. I'm just going to draw a line here to kind of separate what I'm doing through here. So on this next one, we are going to solve, and notice that I don't have what I have in A. I don't have an equation that already has a variable eliminated. So that means I'm going to kind of look and decide which variable might be the easiest to get rid of. In this case, I would probably say that it is easiest to eliminate my z because I already have opposites here. So in order to create a 2x2 system, that means I need to eliminate z or whichever variable you choose from the same equation, or from 2 separate sets of equations. So same variable, 2 separate sets of equations. So I'm going to start with equation 1 and equation 2 as is. So I'm not writing any numbers in front because I'm not multiplying. And I am going to eliminate z. So because I don't have to multiply by anything, really that just means I need to add them together. So x plus 2x gives me 3x. 3y plus y gives me 4y. The z's eliminate each other, and negative 11 plus 1 gives me negative 10. So I've now got 1/2 of my 2x2 system here. So now I'm going to switch over, and I'm going to use a different set of equations and eliminate the same variables. So because we're after opposites, I'm going to use equation 1 with equation 3. I can't do the same two, so I either have to do 2 and 3 or 1 and 3, and I'm going to choose 1 and 3 because this z is already negative. So I'm going to do 3 times equation 1 with equation 3 as is. So because I have to multiply, I'm going to have to write out a little bit more here. So 3 times equation 1 would give me 3x plus 9y minus 3z equals negative 33. And underneath, I'm going to write equation 3 as is. So 5x minus 2y plus 3z equals 21. So now I can add them together because I've got opposites on my z's. So when I add here, I get 8x plus 7y. The z's are eliminated. And then I get equals negative 12. So these two now together have created my 2 by 2 system. So for my 2 by 2, I now need to solve that. And again, I happen to prefer the elimination method. If you like substitution, you could use it. I wouldn't suggest it here because you'd have all kinds of fractions. So because 8 isn't a multiple of 3 and 7 is not a multiple of 4, that's telling me that I'm going to have to multiply both equations by something. So it doesn't really matter whether you eliminate the x or eliminate the y. I'm going to go ahead and eliminate the x's. So that means I'm going to take this guy, or no, I'm going to eliminate the y's. And I'm going to multiply the top by 7. I'm going to multiply this bottom equation by negative 4. And so I've got 21x plus 28y equals negative 70. And then from this one, when I multiply the negative 4 through, that gives me negative 32x minus 28y equals 48. And that's a positive. So then add those two together, and I get negative 11x. My y's are eliminated. And over here, negative 70 plus positive 48 gives me negative 22. So that means that x equals 2. So I've got one of my variables. Now I'm going to plug in. You can either do this equation that has 2 variables or this one. I'm going to choose the top one because the numbers are smaller. So 3 times x, which is 2, plus 4y equals negative 10. So that gives me 6. So I'm going to subtract 6 from both sides. So 4y equals negative 16, which means y is negative 4. So I'm chugging right along here. I've got x and I've got y. So now I'm going to go ahead and find my z. So x is 2, y is negative 4. It does not matter which of these you plug into. Again, I generally am a fan of less negatives and smaller numbers, so I'm going to use the middle equation. So 2 times 2 plus negative 4 plus z equals 1. So 2 times 2 is 4 plus negative 4 is 0. So that gives me z equals 1. Now I've got all 3 variables, which means I can list my ordered triple. So 2, negative 4, 1 would be my final answer on part B. All right, third example here. Now I'm going to go ahead and look to see which variable would be easiest to eliminate. Again, if you make a different choice, that's fine. You should still get the same answer as long as you don't make any computational errors. Because all my y's and all my z's are positive, I'm going to this time choose to eliminate my x's. So in this case, when I choose that, I'm going to choose equation 1 with equation 2, and I'm going to need to multiply equation 1 by 2. So 2 times equation 1 and equation 2 together. So 2 times equation 1 gives me negative 2x plus 4y plus 2z equals 6. Equation 2 stays as is, so 2x plus 2y plus z equals 5. So when I add those together, my x's are eliminated. I get 6y plus 3z equals 11. Then I'm going to choose to do equation 1 with equation 3, which means I'm going to need to change over to multiplying equation 1 by 4. So 4 times equation 1 with equation 3. So negative 4x plus 8y plus 4z equals 12. Equation 3 is staying as is, so 4x plus 4y plus 2z equals 6. So add those together, x's eliminate, my y's, I get 12y, and then I get plus 6z equals 6. Okay, I've got it down to my 2 by 2 now, all y's and z's. Again, it doesn't work if you don't eliminate the same variable, so make sure that you do that. Here now, when I'm looking at my y's, pretty easily if I multiply for my 2 by 2, if I multiply this by negative 2, I'm going to get opposites on my y's. So negative 12y, then I get minus 6z, and then I get equals negative 22. So when I add together then, my y's are eliminated, but my z's are also eliminated. So I get 0 over here on the left. On the right side, I end up with negative 22 and positive 6, which gives me negative 16. So in this case, hopefully you remember this from Algebra 1, but when your variables all drop out, that means you're going to have a special situation and you have to continue it. I often get some people that just quit as soon as they see that the variables are dropping out. You don't want to do that because it's important that you see what's left. And in this case, we see we have left 0 equals negative 16. This is a false statement. So because it's a false statement, that means that our answer is going to be no solution. If what you were to get is a true statement, like 0 equals 0 or 8 equals 8, then this would be a case where it would have infinitely many solutions for you to write. And remember the set builder notation that I taught you to use in the last lesson. All right, last one here. Write in a quadratic equation that passes through the points negative 2, 6, 4, 8, and negative 10, 4. So these ones, obviously, it's not really a word problem, but we've got a little bit more going on than we do in these top 3 that are just straight algebra. When you have this, you have to keep in mind that quadratic equations take the form ax squared plus bx plus c. So what we end up doing, and this would be equal to y, of course, is we end up plugging in each of these points for our x and our y and creating a 3 by 3 system. So I'm going to color code them. I'm going to use this purple for the -2, 6. And when I do that, if I plug in my -2 for my x and my 6 for y, I've got a times -2 squared. So that's 4. So 4a. Then b times x. So b times -2. So minus 2b plus c equals y, which is 6. And then I just repeat the process for the other 2 points. So I'm going to use green here on the next one for 4, 8. So my x is 4, my y is 8. So 4 squared is 16, so that gives me 16a. And then 4 times b, so plus 4b plus c equals 8. Then finally, I'm going to use blue for this point. So here's my x, here's my y. -10 squared is 100, so that gives me 100a. And then minus 10b, and then plus c equals my y, which my y is 4. So now I have a 3 by 3 system. My variables are a, b, and c instead of x, y, and z. So again, totally up to you how you want to approach the solving. I am going to use my c's because they are all the same right now, so it's pretty easy to make those into a 2 by 2. So I'm going to start by doing, and let me grab a different color here. I'll use a pinkish color. And I'm going to do equation 1 with equation 2. I'm going to multiply equation 1 by -1. So -1 times equation 1 with equation 2. So that would change all my signs on equation 1. So I'm going to have -4 plus 16, which gives me 12a. And then I'm going to have +2 plus 4 here, so plus 6b. -c plus c makes the c's eliminated. And then equals, oops, I forgot to put the b here, that's 6b. So then I've got -6 here and 8 here, so that gives me 2. And then I can do my second set. So for my second set, I'm going to do equation 1 with equation 3, again multiplying equation 1 by -1. So I've got -4 and 100, so that gives me 96a. I've got +2 and -10, so that gives me -8b. And then I've got -6 and +4, which gives me -2. So when I solve these, then my 2 by 2 system, I need to either eliminate my A's or my B's. In this case, since my B's have much smaller numbers, I'm going to choose those. So the smallest multiple that I can get would be 24 here. So I'm going to multiply this by 4 and this by 3. So when I multiply by 4 there, that gives me 48a plus 24b equals 8. Then multiply by 3 on the bottom. So 96 times 3 gives me 288 minus 24b equals -6. So now add those together. I get 336a. My b's are eliminated, and I get 2 for my constant. So be careful here. This does not obviously come out nicely. It's not a word problem, so please don't use decimals. There are not decimals in the original problem. So you need to just reduce the fraction. So when I divide both sides by 336, that reduces 336 divided by 2 is 168. So I get 1 over 168, and that is my A value. So now I have A. I need to find B. So obviously you're going to want to use a calculator here since you've got fractions and everything. So if I pull up my calculator, I'm just going to plug this in to my top equation, excuse me, because the numbers are smaller. So it's 12 times 1 over 168. So 1 over 168. And then, let's see, what's on the other side? A 2. So this gives me this guy. If I want to convert it to a fraction, math choice 1, which is 1 over 14. So I've got then 6b here, and I need to do 2 minus the 1/14. So 2 minus second answer. And this is equal to 6b. So if I then divide this by 6, that will give me my solution for B. So B is 9 over 28. So I used my calculator for the entirety of that because of all the fractions. Now finally I can go ahead and find C. So I'm going to use my top equation here. I've got 4 times 1 over 168 minus 2 times 9 over 28 plus C equals 6. So if I want C alone, what I'm really going to be doing is 6 minus this quantity. So 4 over 1 over 168 minus 2 times 9 over 28. So this is what I'm going to go ahead and do in my calculator. So 6, oops, not answer, 6 minus, and then I've got 4 times 168, 1 over 168, and then minus 2 times 9 over 28, and then close the outside parenthesis, change it to a fraction, and I get 139 over 21. So now I can go ahead and 129, or 139, sorry, over 21 for my C. So keep in mind that here I don't want an ordered triple. It asks me to write a quadratic equation. So this needs to be my final answer. The y equals A, which is 1 over 168 x squared plus 9 over 28 x plus 139 over 21. So now I have my quadratic equation that passes through those points. All right, last thing we're going to do is go over and review how to solve a system using matrices. So you learned this in Algebra 2, so this should hopefully be review on the guided notes here. I have kind of screenshots that help you remember what you're supposed to press and what the screen should look like. So I have a 3x3 system example here, but you can use this on 2x2s as well to check your answers. There will be at least one in your homework, the second set that has 4x4s, and it works the exact same way. The first thing we do is we make sure that all our variables are lined up on the left side in columns and that the right side has all of our constants. So x's, y's, z's, constants. Because what we do first is we take the system and we write what's called an augmented matrix. Augmented matrices do not have any variables in them. So you notice how I have this written here. It just takes all the coefficients and the constants just as they are. So 3, -4, 2, 18. And that's what I have here. 1, because nothing's written, 5, -3, -15. And then 5, 2, 3, 20. So you write them in a bracket. That's how matrices are written. And you just space them out enough so that we can tell, that this isn't, 15 instead of a 1 and a 5. It will ask you on the quiz and on the exam, you'll need to write work. So you should, if you're solving using matrices, which if it doesn't specify which method to use, you're allowed to use this method. But you need to write out your work still. So you need to write out the augmented matrix, and then we will write what's called the answer matrix as well. So this is our augmented matrix. This is what we're going to enter into our calculator. So we're following these steps here, and you can kind of follow along. I'm going to bring up my calculator as well. But the matrix menu on your calculator is right here. So you can see it's in blue, which means I have to use the second button. So everything we're going to need is in that menu. There's a names, a math, and an edit. So you can see I've already got some matrices in here because you can see their size dimensions written out. That's okay. You can write right over top of them. So your matrix size, hopefully you remember from Algebra 2 that a matrix is defined first by how many rows it has and second by how many columns it has. So this is a 3x4 matrix, even though it's a 3x3 system, because the matrix has 3 rows and 4 columns. So first thing I have to do if I'm going to choose to edit it is scroll right to the edit menu and then choose the matrix to edit. In this case, I'm just going to choose A. So I edit it and then I enter its dimensions. So 3, enter, 4, enter. You'll notice that when I do that, it automatically changes the size of my matrix. So if you have an older version of the calculator, the numbers are a lot bigger, so you actually won't be able to see probably the fourth one without scrolling on those older values. You didn't do anything wrong, it's just a different operating system. So now what we're going to do is we're going to enter our augmented matrix, and you just press enter after every single number and it automatically scrolls through the rows and then skips to the next row when needed. So my top row, I have 3, then I press enter, then -4, make sure you use the negative key and not the subtraction, then 2, and then 18. See how it skips automatically to row 2, where I have 1, 5, -3, and -15. Then third row, 5, 2, 3, and 20. Always, always, after you've entered it, double check it. So just kind of go through with your augmented matrix, make sure you didn't make a typo when you were entering it. Now it tells you, because we finished step 2 here, that we, and step 3 actually, pressing enter. Step 4 says we now need to return to the home screen. We do that by pressing second mode. So second mode goes back to my home screen. Now that I have a matrix entered, I need to access the matrix math menu. I'm going to be using item B. So I go to second, matrix menu, and I go to matrix math. It says item B. It's probably quicker to scroll up than down, honestly. But we want B, which is RREF. Do not choose A. They look similar. It has to be B. B, that RREF stands for reduced row echelon form, which is the easiest way to solve systems of equations using matrices. So now that I've chosen RREF, I am back on the home screen, so it's showing me what my screen should look like. I have to tell it which matrix to perform that RREF on. So in this case, because my matrix was in matrix A, I'm going to use matrix A. Now you have lots of matrices available to you. You may want to use different ones and not use A every time, because if you end up getting it wrong and you need me to help you, if you no longer have the matrix in your calculator, it makes it hard to do that. So I would recommend not using matrix B or matrix A every single time, unless you are just checking the answers as you go and you know it's right, in which case feel free to just write on over top of it. So now I'm going to do second matrix again, because I have to name matrix A, which means I'm going to stay in the names menu, and I'm just going to choose the value where my matrix that I want is, which is in 1. And so that types matrix A for me. I close the parentheses, and then I press enter. So when I do that, you see that this matches up with what I had on here. This is what we call reduced row echelon form. This is the answer matrix. So in your homework, you are required to write the augmented matrix. So you would need to have this on your paper. Then you would need the answer matrix, which is this guy. And then you would list the final solution. So the final solution in this case, because what this really means is this is 1x plus 0y plus 0z equals 2, which means x equals 2. 0x plus 1y plus 0z equals -1 means y equals -1. And then this last one means z is 4. So x, y, z, ordered triple like that. Now, you do need to be careful. Once you've written down your answer matrix, there are obviously systems that have no solution or infinitely many solutions, which means you can't just always look at the last column. You have to look at this as well. If you don't get this pattern with the ones and zeros exactly like you see it on this one, then it's probably a special case. The two special cases you're looking for are no solution. If you have no solution, that means that at least one of your rows is going to have 0, 0, 0, and then a 1. So if you see that, you can automatically just write no solution instead of a triple. Infinitely many, you're going to have a row of all zeros. The other thing that is really helpful to know when we're dealing with these matrices, in this case, my answers came out as integers, but if they come out as decimals, you can actually convert the entire matrix into fraction form, because we don't use decimals unless it's real life. You just do what you would do with any number. You just basically, when the matrix you have is your last answer, if you just do math choice 1, convert to fraction. Now obviously these ones are already fractions, but it'll take the entire matrix for you and convert everything to fraction form. So that's a really good tip as well. Please pay attention to the directions on your homework problems, because in 7.2, I know that solving those systems by hand is a little time consuming, so I did allow you to use the matrices on some of them, and then the 8.1 section, obviously those are all available to use the matrices on.